All right. So from the first chapter, crop production and management, we had learned about various things. My question to all of you is that you guys tell me what are the necessary precautions one has to take care of while sowing the seeds? What are the
That they're
necessary?
sown at the uniform depth,
Okay, and they should be
proper
sown at
distance.
uniform, proper distance, and
And the sir, they should like cover with soil, properly covered with soil.
okay. So after having sown the seeds, it should be covered with soil so that it is not carried away by wind or not eaten by insects. So good point. And
There should not be overcrowding of plants.
basically the seeds should be sown at right amount of distance from each other. Okay. And what else? There are so many other things that has to be taken care of. Like the first thing, that the soil should be of the right type. Okay, na the, like for example, the kind of seeds and the kind of soil in which it can grow. We should take care of that also. Okay, na? So the soil should be proper. Soil should be fertile. Okay, plus irrigation is also ensured now. For the proper germination, we have to ensure that the humidity is proper. Okay, now. Okay. What
Sir, season?
season exactly? The most important thing, season. Very good point, Gauri. Okay, now. Like for example, the wheat crops. Huh? So like, can we grow the wheat crops in winter? Can we sow the seeds of wheat in the winter, or no?
Yes, sir.
Yes, we can sow. But
Yes,
can we
sir.
sow it in the summer?
No.
No, sir.
Okay, now because the thing is that the favorable temperature required for the seeds of the wheat to germinate is like it requires a
sir.
temperature between 3 to 15 or 18 degrees Celsius, like that. Okay, no, that is the thing. All right. Also, you guys tell me what you guys understand by broadcasting. What is broadcasting?
Sir, it's when you sow the seeds by hand, I think.
Exactly. The method of sowing the seeds by hand is called as broadcasting, right now? Okay. You guys tell me, in order to produce coke, the coal has to go through which process?
Destructive distillation.
Destructive distillation. Very good. Very good. Okay. Further, do tell me that how you will be you guys have that learned the chapter reproduction or not? You guys have learned that, no?
Yes, sir.
Many of you there in the batch. Okay. So did you guys learn about this sheep, the clone sheep Dolly, by the name of Dolly?
Yes, sir.
Yeah. So can you guys explain like how the Dolly sheep, that is the first clone animal, was created? Yeah. How was she created? Sometimes this question could be asked in the exam. Yes. You guys remember anything like the egg cell, mammary gland, anything like that? Huh? Are you able to recall the thing? There was two ships. One was the Scottish blackface sheep. Okay, now. Right now we are learning about cloning. Okay, now. And the first animal to have been cloned was the dolly. It was the name of a sheep. Getting it now? So it was in fact the first mammal. Animals could be of different types, amphibians, reptiles, etc. But this was the first mammal to be cloned by the scientists in the year 1996. So there was a sheep by the name of Dolly. How many of you have heard of the sheep by the name of Dolly?
No, sir.
In fact, there's a statue made of the sheep. A statue is also made of the sheep. Yeah, Chikarika, cloning. The method is cloning, but what exactly is done in the method of cloning, and what particularly was done for this sheep? Okay, na? But before we discuss this, first of all, we need to understand the concept of cloning, like what cloning is. By the term clone, it means that if two organisms are such that both of them are genetically identical to each other, both of them have the same DNA, same genes, so they will be called as genetically identical and they will be clone of each other. Getting it what I'm trying to say? right or not?
Yes, sir.
Like, for
Yes.
example, we have learned how the amoeba reproduces. Basically, it splits into two halves, and both of them are clone of each other. They are identically similar to each other because they have received the same genetic material from their parent. Because they have received the same genetic material from the parent. Getting it now? That is the case. But particularly talking about, like, the concept should be clear. Creation of organisms with a genetic similarity. That is basically the concept of cloning. Okay, in the case of this dolly sheep, let us understand what was done. So first of all, we had the egg donor, which the sheep which donated the egg, and you have the another sheep which was the donor for the nucleus. Getting it? What I'm trying to say? Nucleus donor. Let me complete the whole thing. You will be able to recall it. In fact, okay, na? And anyways, anyway, if you guys feel any doubt, please let me know. And I know some of you might not be having this chapter in the syllabus, but some of you would be having this chapter. Okay, now? So let me quickly finish this. Okay. So there was a fish by the name of Scottish blackface. Okay. Basically, the name Scottish blackface came from the fact that it was from Scotland and it had a black face. The face was of black color. And you have the nucleus donor. Okay, na? And the name of the species of the ship was fin dorset. So these are the species. Okay, Scottish blackface and the fin dorset. Now the Scottish blackface egg was taken out of the body of this Scottish blackface. What was done? Egg was taken. Okay, now. So we have taken an egg. And the fin dorset. Okay, now. So what we did now, we removed the cells from the sheep, or like we removed the cells from the mammary gland. Okay, now mammary gland, basically the gland which produces the milk. So we took the mammary cells. Okay, now some samples from the mammary gland were taken. Okay, now, and we took a cell from it. We have taken a cell from it. Okay, now this is the nucleus of the cell. Okay. Further, what we did now, whatever nucleus material was in this ship now, it was removed. We removed the nucleus from the egg. Remove the nucleus from this egg. Okay. So what we did now, on one hand, we had this empty egg. Now it is empty. It does not have any nucleus, isn't it? Chakrika, Gauri, everyone getting it?
Yes, sir.
Okay. And we took the nucleus from this one. We took out the nucleus. And both of them were combined here. Both of them were combined. Okay, na? So in this manner, basically what happened, the combined cell is now having the nucleus from the fin dorset sheep, and the egg is belonging to the egg donor. That is the Scottish blackface. Getting it now? Okay. So once this zygote is formed, like once this cell has formed, okay, now once a new cell has formed, now this is placed in the uterus of this Scottish blackface. Where is it placed? Now it is placed in the uterus of the Scottish blackface. Getting it, everyone?
Yes, sir.
So now placed in uterus of the Scottish blackface. So who becomes the surrogate mother here? Who is the surrogate mother? Who is the surrogate mother? You guys know about the concept of surrogate mother or not?
Yes, sir.
Yeah, the mother who will not be the actual, I mean to say the mother, but will be carrying the baby in her womb. Okay, na? That is the case of the surrogate mother. So this Scottish blackface is the surrogate mother. Okay. Now, after a few months, when the fetus born, like after 5 months, about 5 months, a lamb is born. A lamb was born. And what we observed in that lamb now, that lamb was not having a black face. Getting what I'm trying to say? The lamb had not a black face. Okay, it did not had a black face. But what we know about the Scottish black face, remember in the beginning what I told you guys, that it has a black face. Remember everyone, it had a black face, but the child did not had a black face. Why is it so that the child did not had a black face? Because the fin dorsal does not have a black face, and the nucleus material was taken from the fin dorsal. That's why the lamb that is born is not having a black face, because the Scottish black face only the baby was present in her womb. Okay, no, it only derived the nutrition from the, like it derived the nourishment from the surrogate mother. So that was the whole case of this. So is this clear to everyone? Am I not audible to you?
Sir, I didn't get it.
You're not getting it. Who else didn't got it? Please let me know. Alif, am I audible to you now or not? Understood, Chakrika? Okay, let me explain it once again. See, basically what was done now, for the first time in the year 1996, cloning was attempted in the case of a mammal. Okay. As a result of the cloning, the lamb that is born here was completely white. So in the case of the dolly, the nucleus of an egg from the black sheep was removed. We have taken the egg from a black sheep. It had a black face. Okay, na? So we took the egg and we removed the nucleus from it. Okay, so now it's a egg with it's an empty egg. It does not have a nucleus. Further, we took the cells from the mammary gland. Mammary gland is found in the body of the mammals, and milk is produced in this gland. Okay. So we took the cell from the mammary gland and we took out the nucleus from it. We took the whole nucleus out of this cell. And now this nucleus from the fin dorsal was put into the egg of the Scottish blackface. So because of this, now a new cell is formed. Getting what I'm trying to say? Now a new cell is formed. Getting it, Gauri?
Yes,
Further,
sir.
this cell is going to multiply now. This cell now starts to multiply. Here it will be like multiplying as well. Okay. Okay. So once it starts to multiply, okay, then this will be now placed in the uterus of the Scottish blackface sheep, in the uterus of this sheep. Okay. So after 5 months, the lamb that was born was completely white. Why it was white? Because it had the genetic material of this sheep and not the sheep. So hope this should be clear to everyone.
Yes, sir.
Okay then.
Sir.
Yes.
So what was the use, like the motive of doing this?
Like why cloning was done?
Yeah.
Cloning was basically done like I mean to say, like, for example, cloning has some advantages, like it has some disadvantages also. Okay, some advantages are like, for example, usually the animal would be cloned. For example, let us say that cloning will be helping us to produce high quality animals and high quality plants. Like, let's say that there's a particular species of cows that will be giving more milk. Okay, now that will be giving more milk. So why the method of cloning? We can produce more such cows now. Getting it? By the method of cloning, we can produce more such cows which are of high breed. Okay.
Yes, sir.
That is one thing. Plus, but it has some disadvantages. Like if the parent has some disease, if this parent has some disease, the disease will be transferred to the child also. If there is some genetic disease, I mean to say. So it will be transferred to the child as well. Okay, no? All right, hope that much should be clear. Okay. You guys now tell me, from the chapter chemical effects of electric current. Yeah, we had learned various things in that chapter. You guys explain to me what is an electrolyte, what is an electrode, further what are its types. In the case of electrolyte, you will be required to give some examples also. Answer this much first of all. So has cloning ever been done on humans? No, on humans it hasn't been attempted. Okay, no? And that goes against the laws. There are various law bodies that will not allow the scientists to perform such a risky experiment. Okay, no? Although now science has progressed, so I think that if it were to be done, it will be kind of successful. But there, who knows? It can go wrong. Okay. Yeah, you guys answer this question now. What is an electrolyte and give its example? Yes, Abdullah, Khadija, Alef. I guess I'm audible to everyone.
Sir,
Yeah, answer the
sir,
following question.
like,
What is? Mhm.
sir, my internet was bad. I leave the class. Then I cannot like. Now I got the internet. Can you explain one more time that egg donor?
Which one? See, Alef, now, dear, please, you can watch the recording because if I were to repeat it again, like it will be taking around 10 minutes. So kindly adjust for today. Okay. Yeah. Yes, Abdullah, Gauri. Mhm. Yes, what happened to you guys?
Sir, it is silver.
Silver? No.
Yes.
How can silver be an electrolyte? It can be used as an electrode.
No, donor. Sir,
Repeat again. Gauri, haven't we learned about all this?
Yes, sir.
Yeah,
We
Chakrika.
have.
Very good, Chakrika. Copper sulfate is an example of electrolyte. Basically, acid, base, salt, all these things. Plus any kind of impurity added in water will be acting as an electrolyte.
Potassium.
Not just potassium, it could be potassium permanganate, potassium chlorate, like that. Okay, no, not a single, it should not be a single substance. Okay. Like copper sulfate has copper in it, sulfate and sulfate is it found in it. What we have learned about electrolyte, that electrolytes are any given compound that will allow the electric current to pass through it. Any given compound in the liquid state that will allow the electric current to pass through it. That's the concept, okay, na? Okay. Talking about electrodes. So there are two types of electrodes now. What are the two types of electrodes?
Cathode and anode.
Cathode and anode. Very good. Okay, Chikrika, you have given an example. By the way, I asked for the type, but that is okay. So cathode and anode. Okay, out of the cathode and anode, which one is a positively charged electrode?
Anode.
Anode is the positively charged. Very good. And the cathode is the negatively
Negative.
charged. Okay. We know that there are two type of ions, positive and negative. Which one is positive ion and which one is negative ion? Yes. One is cation, another one is anion, right now? Cation and anion. Okay. Out of the two, which one is positive charge?
Cation.
Cation is positive charge and anion is negative charge. Very good. Okay. From the chapter, I'm thinking to discuss some questions from the chapter force and pressure today as well. Okay, now. So from the chapter force and pressure, first of all, you guys tell me what is the unit of force?
Sir, Pascal.
Newton.
That is Newton. Okay. Okay. Further, you guys tell me what are some of the important properties of force? Yes.
Sir, it can change the direction of an object,
Okay, it can
and it can change the shape of an object,
change shape.
and the speed
Which one?
of an object.
Speed. Okay. Okay. What were you guys saying? Others were also answering this.
The shape and size of the object.
Shape. Okay. Let me add size as well. Good. And
Can change the motion of an object.
okay, basically state of an object. If it
Yeah.
is in motion, bring it to rest, or if it is in rest, bring it to motion.
sir, speed of an
Yeah, that has been included here. Good. Someone who's trying to speak, but I can hardly hear you. Shakrika, are you saying something? I can't hear you. Yeah. So, and a force can bring about these changes. It can change the direction, change the shape, speed, size, and state of the object. Right now. All right. Talking about pressure, what is the unit of pressure?
Pascal.
Pascal. How is it written in short?
Sir, PA.
Capital P, small a, right? Like this. Okay. What is the unit to find pressure, or like formula to find the pressure?
Force by area.
For those who are saying force upon area, that is correct. Okay. You guys tell me, what is the relation between force and pressure?
Sir, there is atmospheric pressure like that. Force is like magnetic force like that.
Not in that manner. Basically, I'm saying like how is uh, force and pressure related here? Like, is there any relation between force and pressure?
Force divided by.
No, that's a different thing. That's a pressure equals to force upon area. I'm asking, is there any relationship between force and pressure?
Sir, like if we increase the force, then pressure will also increase?
Exactly. Okay, no? So when you increase the force, the pressure is also going to increase. Getting it, guys? Okay, no? That is the thing. So pressure is directly proportional to force. What is being said? Pressure is directly
Directly.
proportional to force. Good. Now, my another question to you guys is that what is the relation between pressure and area?
Sir, when area is less, pressure is more. When
Area is less.
area is
Hmm.
more,
Hmm.
is more, pressure is less.
Hmm. So they are sharing a inverse relation, isn't it, guys? They are sharing a inverse relation with each other.
Yes.
Good. So inverse relation is observed. Okay. Further, you guys tell me that I'm going to give some examples. You have to tell me which one of them is a bad conductor of electricity. Okay. Distilled water, then you have silver nitrate, and let's say we have sulfuric acid. Then you have copper sulfate. Out of these, which one is a bad conductor of electricity?
Distilled water.
Distilled water, you're saying. What about others?
The distilled water.
That is distilled water, undoubtedly. Very good. Okay. Do tell me that we have learned about petroleum right now. Do tell me what is the full form of PCRA? What is the full form of PCRA? Yes, Gauri, Abdullah, Khadija.
The Petroleum Conservation Research.
Just research or like association?
Yeah.
Okay,
Petroleum Conservation Research Association.
okay, very good. Okay, no. Okay, say you have such a question. I'm going to draw a Venn diagram. You guys understand what is a Venn diagram?
No, sir.
Okay, let me explain. Let me just draw this thing. Traditional. We have irrigation method. And let's say you have modern here. Okay. This is P and this is Q. Okay. You guys tell me what could P be and what could Q be? what this P could be and what this Q could be. Should I write the options?
Yes, sir.
Option number A says that P could be chain pump while Q could be drip system. Is this true? Or option number C says that P could be Dhekli system and Q could be moth. Option number B says that P could be the sprinkler system or Q could be a Rahat system. You guys have learned about Rahat, Dhekli, moth and all this now? Different
Yes,
methods of irrigation. Okay. Or let's say P is a drip system and Q says that and Q could be the Dhekli system. What do you guys think is the appropriate answer?
Sir, A.
Okay, what about others? Everyone answer this. That is?
B.
Also,
Let's see what everyone has to say. Yes, Chakrika is not here. Alif, Abdullah, Khadija.
sir, I don't think they are right.
Yes, sir.
Okay. You don't think any of the options are right here?
Yeah,
Actually, one of them is right here. Okay.
but
See the
okay.
so like there are three circles here.
B1 is right.
B1 is right. That is P is a sprinkler system and Q is Rahat system. And Q is the Rahat system. Okay. See, first of all, P and Q, both of them are going to be irrigation are going to be irrigation methods since they lie inside this circle now. Right now, they are the irrigation
Yes, sir.
methods. It is within this circle. Okay. Where is P? P is within this circle now. So P must be a traditional method of irrigation, right? P has to be a traditional
Yes.
method of irrigation now. Okay. Let's start by eliminating the option. Option number D says that P should be drip system. So here you are going to cancel out the option number D. Understood why I'm canceling this?
Yes, sir.
Because as per our understanding, P is going to be a traditional method. Okay. We are going to cancel option number B also here. Getting know why?
Sir, correct answer is A.
A, exactly. Okay, now because option number C, guys, it's saying that the Q in the question, it's given that it should be a modern method, but Q here is moth, but moth is a traditional method of irrigation. So thereby option number A is correct, that P could be a chain pump, okay, while Q could be the drip system of irrigation. Okay, answer one question. Out of the drip system and sprinkler system, which system of irrigation can be used on uneven land?
Sir, sprinkler.
Sprinkler, you are saying. What about others? Yes. What do you guys think?
Same, sir.
Same? Very good. Okay, no? Okay. You guys tell me that we have learned about various things like in the chapter microorganism friends and so forth. We have learned about different things. Can you guys tell me that what was the work done by Alexander Fleming? What is he known for? Yeah. What is Alexander Fleming known for?
Sir, vaccine.
What was the name of that vaccine?
Penicillin.
Penicillin.
Unfortunately, that was not the vaccine actually. It was the antibiotic. Penicillin was the first antibiotic. Getting it? Alexander Fleming was known for the discovery of the penicillin. Okay, now? So he helped in the preparation of the world's first antibiotic, that is penicillin. Celine. Talking about the vaccine, it was the Edward Jenner, no, guys. Vaccine was first made by the Edward Jenner. Getting it? Where he discovered that a persons who are earlier contracted with the cowpox were now immune to the smallpox. Anyways, by the way, this person Alexander Fleming got Nobel Prize for this work actually. Okay, now. Okay, you guys tell me that the species which is going to become extinct due to the lack of proper care, what they will be called as? Will they be called
Endangered.
as? They will be called as endangered. You're saying, or will they be called as extinct or endangered? What do you guys think? That will be, of course, endangered. Okay, now. Okay, you guys tell me, what does the red data book contain?
It consists of a list of the endangered and extinct animals and plants.
Not just animals and plants, but the fungi also. Okay, now fungi as well. Getting it? Okay. Do tell me that in order to do electroplating, for example, let's say in the process of electroplating, the sample which is to be electroplated. My question is that in the process of electroplating, the material which has to be electroplated, so that is made cathode or that is made anode? You guys able to understand?
Cathode.
Okay, you're saying cathode. Everyone saying the same answer or different?
Yes, the same.
Same? Very good. Okay, na? That is the thing. Okay. Further, in order to perform electroplating or basically electroplating, what are the necessary criteria one has to fulfill? What are the necessary requirements to perform electroplating? Yes. The first and foremost thing is that you should have the right electrode. Okay. Say you want to do the deposition of copper on brass. So you should have a copper and a brass electrode. Another thing is that the electrolyte could be any salt, could be any substance, but it should have copper in it. It should have the same metal that is going to be used for electroplating. Getting my point? What I'm trying to say? Say you want to do electroplating. So you have taken two electrodes here, cathode and anode. This is cathode. In order to make this cathode, which terminal of the battery it has to be connected to? In order to make this cathode, it has to be connected to?
So can you
Anyone?
repeat?
In order to make this one cathode, it should be connected to which terminal of the battery? Positive or negative?
Positive.
You're saying positive. What about others? Why we're going to connect it to the positive, guys? Cathode is negatively charged, no?
Yeah, we will connect it with negative.
Negative terminal. Okay, no? So you're going to connect it to the negative terminal. Okay. So we have chosen the right kind of electrodes, plus the terminal of the battery to which it has to be connected, that should be proper. Further, the electrolyte that I am going to choose, it must contain the metal in it. It could be any substance, but the condition is it must contain the metal in it that is going to be used for electroplating. For example, here you have taken copper and here you have taken brass here. So which metal is being used here for deposition, for electroplating? Which is being used here? Copper is being used here now for electroplating, isn't it? So the electrolyte must contain copper in it. Everyone got this now? The electrolyte must contain copper in it. Okay. Okay. How about we do some questions from friction as well? Right?
Okay, sir.
Okay. You guys tell me if you guys have any doubts from the chapter friction. Yes. If you happen to have any doubt from that chapter, you let me know. Okay. Okay. Otherwise, answer this question. Say that there are different persons who are trying to arrange the forces in the decreasing order. So some of them, like they have arranged the different forces in 4 different ways. Some of them arrange it in this manner. You had the rolling friction, then you had the static, and then they had the sliding. You have to arrange them in the decreasing order. Okay, now some of them arrange it in this manner: static, rolling, and then sliding friction. Some of them have arranged it in this manner: sliding, static, and then rolling friction. Okay, and some of them arrange it in this manner: static, sliding, and rolling. So which one of them have arranged the friction in the decreasing order in the correct manner?
D1.
Okay, what about others?
Sir, D.
D1. Exactly. Chikrike, is there some network issue with you today? You guys answer some more questions. You guys tell me why, like for example, say for example, there is this wooden block. Okay, and forces, we are applying force on it. Okay, no issue. So we are applying force on it from 4 different directions. From this side, let's say from 3 different directions. From this side, this side, this side, and this side. And these are the different values. You are applying a force of 10 Newton, 25 Newton, 35 Newton. Okay, now 35 Newton. And let's say that you are applying a force of 25 Newton from this side. Let's just increase it to 20 Newton. Okay. You guys tell me in which direction the body is going to move. The block will move in which direction? This is, let's say that this one is the north direction, this one is the south, this is east, and this is west. So in which direction the block is going to move? What do you guys think?
In east.
East.
What about others, Khadija? Aleph, Chakrika?
Sir, East.
That is in the east. Very good. Why is it so? Because why is it so?
Because both the forces on the west and south are the same.
So here, when we calculated the overall force on the object here, so we found that from the left direction it's 45 Newton, but from here it's 35 Newton. So there is a net difference of how much? 10 Newton here. Getting it? Now? So thereby the body is going to move in this direction. With how much of force it is going to move? So with a force of 10 Newton, it is going to move. Okay, now? So that is the case. Okay, you guys tell me how the friction is acting as a foe. How friction acts as a foe and how friction acts as a friend. List down some of the examples where it is helpful, while here in some cases it is not helpful.
Sir, it's helpful for writing.
Yes, yeah, for writing. Okay,
So we can walk and run because of friction. We can
Okay.
hold an object because of friction. And
Okay.
also vehicles are able to move on road.
Okay, all right. So in this way it is acting as a friend, and there are so many other ways in which it is acting as a friend. Yeah. Yes. Like imagine if there were to be no friction, would we able to apply the brakes?
No,
Yes,
sir.
sir.
No. So it helps to reduce the speed of the vehicle or allows to stop the object. So reduces speed plus allows us to apply the brake and stop any moving object. Okay, so these are some of the ways in which it is acting as a friend to us. Okay, and how is it acting as a foe?
So various movable part of machines produce like heat And this heat can like damage the parts of machine.
So it produces heat, and heat can lead to wear and tear. Okay. And yes. Yes, Khadija, Abdullah. Like we know, it will be causing damage to the parts of the machines and the tools. And if like the industrial tools and industrial machines are getting damaged, so heavy cost will be required to repair them. So it will be leading to financial loss as well. Getting it what I'm trying to say? So it damages parts of machine, okay, and it can lead to the financial loss as well. That is one thing. Plus, it kind of produces hurdles in moving the any object freely on a road, right? It it reduces the speed of the moving object, so thereby more force is required to move the object smoothly. Since it
Yes.
exactly so reduces the speed, so thereby you have to apply more force. So where are you going to get this more force from? So basically the engine has to be provided with more fuel. Engine would be consuming more fuel in order to walk on a bumpy road. Getting what I'm trying to say? So thereby fuel will also be wasted now. Fuel will be wasted, plus your time will also be wasted. Okay now. So that is also one thing. Okay. Okay, Khadija, you had doubt from the chapter combustion and flame. Okay, can you list down the doubt in the chapter combustion and flame? If there's any particular topic in which you're having doubt, or like the whole chapter, so that we can discuss the specific topic. See, in the chapter combustion and flame, Khadija, you there in the class now? The
Yes, sir.
chapter combustion and flame, we had learned various basic things in the chapter. Okay. By the way, you guys will be staying for 5 more minutes after the class, 5 more minutes. Okay, na? Since I joined late today. Okay. So what we have learned about combustion, basically it's a chemical process in which a substance will undergo reaction with the oxygen to give heat and light, right? In some of the cases, light is not given off, but generally, uh, the object will go under combustion in which it will be reacting with oxygen. As a result of oxygen, it will be giving the heat and light. In some of the cases, it does not give light. Getting it now? Like what kind of example do we have in which the fuel is not going to give light? The substance is not going to give light. For example, you have some potassium or sodium. Okay, na? So when it is left in the air, it also react. It starts to react with the air. So it will be hot. It will be hot, but it will not be giving light. Getting it? What I'm trying to say? Okay. That is something which we learn. Then we learn that there are two kind of substances. Substances which we catches fire easily, they are called as combustible substances, like paper, coal, and wood. And there are substances that does not catches fire easily, like sand, water, glass, rock, etc. Right now, further we learn in order for for a combustible substance to catch fire, it requires some important thing, like it requires adequate supply of oxygen. It requires required temperature or required amount of heat at which it will catch fire. That is called as its ignition temperature. Plus there has to be a fuel. So these were the necessary conditions for combustion to take place, right? And there was this activity to prove that how oxygen is required for combustion. So you have taken three setups. In one of you have placed this glass chimney over the wooden blocks, so that air is entering from the bottom, and from above also air is accessible to the candle flame, so thereby candle flame will burn smoothly. But in this case, you have removed the wooden blocks, so the chimney is no longer resting over the wooden block, so the supply of air from beneath has stopped. Getting it, everyone? So after some time, the flame extinguishes. And in this case, you have removed the supply of oxygen from the air, from the above as well. Okay, so within few seconds, this will go off. It will extinguish. So this proves that oxygen is required for combustion, basically. Okay, na? So those were a few things we have learned. We learned that there are different types of combustion, namely 3 types of combustion where they are. Like we have the rapid combustion, spontaneous combustion, and explosive combustion. In the case of rapid combustion, combustion was very fast. In spontaneous combustion takes place on its own. You don't have to provide an external source of heat. Getting it now? Abdullah, Khadija, Gauri, everyone, right?
Yes, sir.
In rapid combustion, like you when you bring a matchstick near to the stove, when you bring a matchstick near to the stove, does it take several minutes for the LPG gas to burn, or does it catches fire instantly? What we know, it catches fire instantly, isn't it? It instantly catches fire. Okay, so that is the example of the rapid combustion. Okay, now spontaneous, we have several examples. Remember moments ago I was giving the example of sodium metal, sodium or potassium. If you were to
Yes,
left
sir.
it in the air, now it will automatically it is going to react with the oxygen present in the air. You don't have to heat it. So that is also a spontaneous combustion. That is combustion on its own. But in the case of explosive combustion, a large amount of heat, light, and sound is produced. We have the example of the firecrackers. So where I had explained to you guys that why the sound is produced. Okay, so what basically happens due to the excess amount of heat released in this explosive combustion, the gas that is released now, it expands abruptly. It suddenly expands. So due to the sudden expansion of the air molecules, of the gas molecules, the sound is produced. Okay, na? And you get to see this also, like when this jet aircraft moves in the air, and when too much of air molecule builds in front of it now, so there comes a time that a huge sound is produced, and that is called a sonic boom. Anyways, that is one thing. Further, we learned about what is a fuel. So we learned that fuel is basically a substance that will be giving off a significant amount of heat upon burning. Okay, now so we have only some of the substances can be called as a fuel, not everything. Like you can't call a rock as a fuel. Like rock can also be burnt. Okay, now like it can be also be heated. If you were to heat it up to 5,000, 6,000 degrees Celsius, it will also burn. But the thing is that will it be a suitable fuel? Will it be called as a fuel? Actually, no. Getting it now? So fuel would be anything that will be having a that will be giving sufficient amount of heat upon burning. It should be easy to burn. Okay, it should not be very difficult to burn. Okay, we learned about the concept of the ideal fuel. That but it does not exist basically. But what we learned about the concept of the ideal fuel, that a fuel that will be burning without producing any residue, it will be giving high amount of heat, that its calorific value should be very high. It should not give any toxic gases like carbon monoxide. It should be easy to store and transport. It should be cheap. It should be available everywhere. But that kind of fuel does not exist right now. Then we learned about the calorific value of the fuel. So calorific value basically tells you about the efficiency of a fuel. I mean to say that it basically tells you about the amount of heat that is given off when you burn 1 kilogram of a fuel. So see that you have 1 kilogram of a fuel, and if you were to completely burn it, if it were to go under the complete combustion, getting it what I'm trying to say? Getting it, guys? So when it goes under complete combustion, upon burning, the amount of heat that will be given off, that will be called as the calorific value. And the unit is kilojoule per kilogram. Which one of this has the highest calorific value?
Hydrogen gas.
Okay. So like hydrogen gas has the highest calorific value, but why can't we use it in the vehicles? Why can't we use it in the vehicles? And why can't we use it in for domestic purposes? Why can't we use this? Yes, Alif, Khadija. For the domestic purpose, this hydrogen gas, why can't we use this? Yes,
Sir, is it because there is just hydrogen gas?
I can't hear you properly. Gauri, what were you saying?
Sir, it is not eco-friendly.
No, it is actually less polluting now. The thing is that there are several reasons for this. First thing is that it is not easily available. Another reason is that the cost of the production of hydrogen fuel is very much high. It is very much costly. Getting it, guys? Now, all if you can remember the process of electrolysis which we have done. Can you guys recall the concept of electrolysis, where the water was being broken down with the help of electricity into oxygen and hydrogen?
Yes, sir.
Right now, so electrolysis has to be done in order to produce the hydrogen gas, but some other processes are also done, but it's a costly process plus a time consuming process. That's why it cannot be done. We did solve some questions on the calculation of calorific value also. Then we did learn about the working of the matchstick in the chapter. Okay, now so we learned like how we learned about the history of the matchstick. It is about 5,000 years old. Okay, now the history of the matchstick is very old. It's more than 5,000 years. Okay, nowadays we use these things in the matchstick. Okay, now we use red phosphorus, we use powdered glass, we use some of other substances in it. Basically, what happens when you rub the head of the matchstick on the box here? So the red phosphorus in this, due to friction, it burns and it converts into white phosphorus. So the main component of the bulb of the matchstick here is the red phosphorus, which turns into white phosphorus upon being heated. Where is this heat coming from? This heat is coming from the friction when it is rubbed on the matchstick. Okay, now on the box, I mean to say. And what we know about white phosphorus, it spontaneously ignites. White phosphorus is very much reactive. So it is going to do spontaneous combustion, thereby the temperature of the wooden stem increases, and the wooden stem now has reached its ignition point, and then it is going to start, then it starts to burn. So that is one thing. Okay, now further we learned about this activity in the class. We did learn about this, in fact, like when we have put the water in this filter paper, the paper is not burning. Why is it so? That this paper cup burned, but this one not burned. The main reason was that it did not reach its ignition point at that time. The presence of water lowered the ignition point of the paper here. So that is something which we learned. Okay, we learned about how we can extinguish the fires, what are the principles of extinguishing the fire, if we can eliminate the supply of oxygen, or if we can eliminate the fuel, or if we can lower the temperature. So these are the principles of extinguishing the fire, isn't it, guys? Right? We did learn about the working of the fire extinguisher also. Okay, now it's true, one thing, we'll be taking up this topic in the next class. Other students are actually waiting for a different batch. Okay, now so we'll be stopping here, and Khadija, list down your doubts to me in the next class. We'll be continuing from here in the next class. All right now.
Okay, sir.
And in the next class, all of you be present, because I'm going to take a class test for all of you. There will be questions from all the chapters which has been done in the batch so far. All right now. Particularly, it will be based upon your upcoming exams. Okay. Okay then, guys.
Bye, sir.
Yes, bye.
Bye, sir.